difficult to set it up? Or
I don't, yeah, I see something.
set up assistant. Let's just hit continue. Will not be useful because it's identified. Continue. Identify your keyboard. So shift
And then down.
Oh, are you sure that it's
Might not be,
it's shift? Shift set? No. Select the keyboard type. I guess this one. Okay, see maybe. Yep. Oh, wow.
And then here's
Oh, thank you.
You're welcome.
Yes. All right, everyone. Thank you for coming. Today is a quadruple presentation, not by 2, but by 4, plus ones for both of us. So my presentation is about metadata and using GPT to extract information. And I'm Dany, I come from the Marin Group, Bioinformatics, and I hope you'll have fun. Okay, so annotating microbathless samples based on metadata. Microbathless is a website that our lab created. It's a database with all the publicly available samples out there that we download and reprocessed and display them on this website. And each sample comes with metadata. For example, this one. Here you see sample, the sample ID. It's a water sample, that's why it's blue. And this is the original metadata. So the original metadata means it's the metadata that the submitter submitted when submitting the sample. And it has fields. Some of them are compulsory and most of them are not, are optional. But there is mostly no scroll down menu where you can just pick things. It's very arbitrary what you can fill it out with. So it's very messy to parse. It's very difficult to parse. Before I came here, the microbathless metadata was annotated. It's still annotated, and by using white lists, black lists of words. So these words not, these words yes, and using natural language processing like stemming, changing plurals, singulars. And keywords were extracted in an automated way. So it's millions of samples. You could not use people to do this. So these were the keywords, for example, that were automatically extracted here. And based on these keywords, it was determined that the biome was water rather than animal or soil or plant. Yes. So here you have another sample. It's gray. It's unknown what the biome is. This is the original metadata. And why is it unknown? Because the keywords extracted are all of these, and you see that they all point to different biomes. Forest points to plant, insect points to animal, soil points to soil. So it could not be automatically determined what biome it belongs to. Then at the end of 2022, 2023, someone told me about GPT and I started using it a little bit and I thought like, wait, maybe we could use it for the job that I should be doing in other ways. And also I have tried other techniques to with no success. So let's see what GPT does. So I asked GPT one day, make a summary from the metadata that I give you. Guess where the sample comes from out of these biomes. Guess the more specific nature of the sample in less than 4 words. Extract geographic location. And also tell me when the sample was taken. And so this example of this metadata comes from Janko because he was the one who inputted this into GPT one day. And you can see a few things. You can see here Komodo dragon, sebum, mice, rats, rabbits, skin, inguinal region. You can kind of get an idea what it is, right? And GPT made a beautiful summary, guessed exactly, animal. It told me the biome. It told me that it comes from Komodo dragon skin. It comes from Atlanta, and the sample was taken on this day. So I did a nice job. So this is our ontology on Microbatlas. It's 4 different biomes. These are the biomes: water, soil, plant, animal, or unknown. And the sub-biome are the subcategories of each. So taking one sample, I wanted to use OpenAI, GPT, to extract the biome. For example, water here, the sub-biomes, marine, where it comes from in terms of text, so not coordinates, but text. It comes from I don't know how to pronounce that, in Japan, and to extract 5 to 8 keywords. That's the job that I gave to GPT. And I've learned a few things, but before I jump to the GPT findings, I'm going to show you what I meant by messy metadata. One cannot just, by looking at one single field, know where a sample originates from. Where is the pointer? So here is, for example, which fields report the origin of the samples. And most origin of the samples you will find in the abstract, in a field called study abstract. But of course, it's a lot of text, it's a lot of parsing. And the second best is, your second best guess where to look at is sample scientific name. But you can see that it's nicely distributed where you can find the origin of the sample. So you cannot just take one field and discover where a sample comes from just by looking at one field. And then metadata is also bulky, and if you do an initial cleaning, you spare on the number of tokens that you submit to GPT. And we reduce the size by like 30% by doing some pre-cleaning. Now, GPT findings. Large language models outperform previous NLP-based techniques in annotating samples. I made a benchmark biome out of 1,000 samples with equal numbers from each biome. These are the biomes. And then I did a prediction with GPT, and I got these results. And this is the benchmark biome against the biomes that were obtained using the keyword-based classifier, which was the previous method on Microbatlas. So that method using NLP. And you can see that a lot less sample end up in other or unknown than they do here with the old method. And we get better scores than with the old method. And then we ask ourselves, how does GPT compare to a human in doing this task? Because we were always seeing this 80% accuracy, 80%. It would never go up to 85 or 90, just that was the upper limit. And we were like, what if we ask another human to do this biome classification and see how he does? So we let GPT do the job, and then we let another human, a biologist, I'm not sure if he's among us. I actually don't know his face, but I don't know his face. George Hausman. That's your job here. So you did a little bit worse than GPT, yeah. but then we gave a better prompt, a prompt with one extra sentence saying, for these difficult samples, we noticed that rhizosphere samples and sediment samples were a bit hard to categorize. So we say to GPT or to George, If they are rhizosphere, put them in plant, and if they're sediment, put them in water. And GPT did better. And George did much better. So much better. And actually this difference is significant and this one is not. So it seems like a human can do better at better prompt when given a better prompt. Another finding is that the geographic location from GPT can be used to flag potentially wrong coordinates. So we have the extracted coordinates, just coordinates, and we map them against what GPT found. So if they don't match, then we can say, we're not so sure about this. You cannot curate this data manually, right? So it's one way to use the GPT output. And then a side note about metrics, because I don't want to confuse you with something that is really, really trivial. So when you see the blue and the orange, exact match, lenient match, that's what I mean. So if the benchmark is saying animal, and GPT is saying animal, and then it puts something extra, then it's not an exact match, but it is a lenient match. That's what I mean by exact and lenient match here. And average similarity refers to the subbiome. The subbiome is the origin of the sample, like human elbow. So if the benchmark says human elbow and GPT says human elbow, then you have 100% similarity. If the benchmark says pig feces and GPT says pig stool, then words-wise they're not the same, so you get a little bit less similarity. So we're looking with these two things, we're looking with the top two and the bottom one, we're looking the top two at the biome and the bottom one at the subbiome. So we did performance tests on to see how GPT performs, right? And I was a little bit cheap while using GPT, and I thought, like, I want to ask my big question only once, and then attach the metadata, all the metadata maybe of a few samples, instead of sending one question and one metadata each time, which costs more money, right? So I did that, only one at a time, or a few at a time. Up to 15 is the maximum that I tried, a median of 15. And I did like performance. I measured the performance. And it seems that it's all right until pretty much this. So you can, up to like median 5 metadata texts at a time, it's all right. There's no significant difference, but then it drops. It drops from here for subbiome, in guessing the subbiome, and here the biome. Yeah, but I did not go, the production run, I did not do any chunking because it was cheap anyway. But it was a nice thing to find. And yeah, it seems that it gets forgetful. You know, the more stuff you put in there, it gets forgetful. And where it gets forgetful, towards the middle and the end. Like the first ones, it might get right, and the middle and one, it makes mistakes. I compare models. GPT-4 is better than GPT 3.5 turbo, but not by much. You can see GPT-4 and 2 different models of GPT 3.5. Creativity parameters. The long story short is that the creativity parameters, there's 4 for GPT: frequency penalty, presence penalty, nucleus sampling, and another one. And I tried different settings of these ones, right? Because I wanted to see what is the perfect, how do I tweak these parameters to get a better output? And the long story short is that it did not matter. For our task, it did not matter how you tweak these parameters. It did matter only in this case. With the frequency penalty going up at 1, you see that there's like a drop in the score, in guessing the biome. And that's, for example, because this is not exact match, but this is a lenient match. And that's why when you do the lenient match, it's recovered. And also when you don't do the chunking and you send the question only with one sample, then you see no difference in performance. We learned that it's good to ask for a JSON format in the output. It's better than asking for an inline output because it's better at parsing. Yes, it costs more money because it takes more tokens in the output, but it's better in the end. And then, even though there's two ways of asking GPT for requests. One is asynchronous and one is synchronous. And I was wondering, is there a difference in performance in between the two? All these are the asynchronous and these are the synchronous. And there's no difference. And in fact, there should not be a difference, because if you use the same model, the same parameters and everything, there should be no difference. And in fact, there is not. Limitations, one thing that we found out pretty early in the analysis is that one should not expect GPT to know the meaning of ontology codes. Ontology codes are, for example, envo, colon, 1, 2, 3, 4. And that corresponds to human elbow, plant leaf, yeah? But you cannot give the metadata as is to GPT containing these envo codes and hope that it guesses it right, because sometimes it makes mistakes. Sometimes right, sometimes it's wrong. This conclusion is based on something that I've done 1 year ago. I don't know if it's still the case, but it was making things up, things like that. So you should not use GPT to, in my opinion, as a dictionary. You should do the mapping first, and then this envo code, it gets translated into text, English text, and GPT can understand it. And then you feed that to GPT. Our ontology, biomes and subbiomes, is far from perfect. In fact, even for a curator, some samples are hard to classify into our 5 biomes, as George knows. However, it is a fact that as a community, we have not agreed on one single metagenomic sample ontology. This affects generalizability and reusability. The silver lining is that we can use embeddings of subbiomes to assign samples to new ontologies. That's theoretically possible. The manuscript has been submitted. I'm now in the process of containerizing the code because an editor asked me to. And then, yeah, I did the production run. And the production run from this number of samples to 1 million samples, it costed this much money, and it would take this long, 6 hours. This is an example of an output from GPT. This is a sample ID, and this is the keywords, 5 to 8 keywords. This is a subbiomes, sample ID, and the origin of the sample, which is the subbiome. What GPT does, another model, takes a text, subbiome, and translates it into embedding. It's a vector of 1,536 numbers. And then what you can do is, you can make the embeddings, these embeddings, you can make them based on the keywords, or you can make them based on the subbiomes. And then you can see them clustering here. They are here colored by the biome label. So you see the animals clustering together, the plants and the soil clustering close to each other, kind of like mixing food samples. And the best clusters that we got is when we use an average of the keywords embeddings plus and the subbiomes embeddings. What can we do with this? Yeah, we can do cool things like we could theoretically from an OTU table guess that is what a sample is. We can say this OTU sample looks like a freshwater sample. Or what does a freshwater sample look like? This is the composition, the microbial composition of what it would look like. And you could learn that from a lot of samples. And the problem is that we don't have, even with 2 million samples, it's still not enough because we have too many features. So the number of unique subbiomes that we have is 105,000. Yeah, unique. But if you get rid of the singletons, you have 48,000, which is a little bit better, right? But still too many. And my problem now is, how do I cluster? How do I get from 50,000 to 1,000, let's say? And if you have ideas, please let me know, or we can discuss later. And I want to thank my group for all the suggestions along the way, and CCR, and you for listening. And I will take questions now.
other humans other than George?
I think it's pretty robust. I don't know. I think it would still like, because some things are just difficult to classify into those categories. Yeah, some, I don't know, very, very strange things like, yeah, a cadaver. At what point a cadaver, microbiome sample from a cadaver falls into like animal or soil? What, like how old, you have to know like how old it is, right? I don't know. Some things are just hard to classify.
Super interesting observation of this chunking losses. I was wondering, like, do you think this is mostly attention bound, of like the model kind of stops paying attention when the prompt is too long, or could there be a point where, like, if one can tune this, the model, if it sees more inputs, it like learns from like what patterns emerge across different inputs it gets, and might try to unify some of its classification more because it sees similar patterns, and then you might not be able to match them to the original because it wasn't matched that way, but the model could start learning similar things.
I don't know how it does it. I mean, it's 15 questions at a time, and it doesn't know about other tasks. It only knows about those 15 at a time. So maybe, you know, it could be a little bit dangerous if you feed 3 samples that are from water in a row. Then it's maybe more likely to say that the next is water. I mix them up in a way that they're, you know, randomly random. But yeah, it's dangerous to use too many. I mean, it costs more, but it's better to ask the question, unless they are metadata that are really short, right? This metadata can be large, small.
Could GPT now also help with summarizing your subbiomes? Did you consider to just send, you know, a subset of now classified?
Very tempting, but you would need to put like all the subbiomes, for example, that you wish. Yeah, it's the problem of, for example, in this biome, we say classify into these 5 biomes, and it's only 5. And it's still like sometimes make mistake and say something extra or different. Rare, but it happens. But if you would make this list longer, it would definitely happen. I think it would definitely happen, because to keep it restricted to like a choice, I wouldn't know how. For sure, maybe something like with the tree, you know, hierarchically, like if it's that, and then you ask another question.
Suggest a kind of a sub-selection, and then you classify the samples. Otherwise, to this suggested sub-selection, because it's pretty good at summarizing things.
Yeah. I have to think, yeah, possible. I don't know who was first. Let's go. Yeah.
Yes, did you try out the GPT Pro version? Because I think that can handle 200,000 tokens compared to the 20,000 tokens which 4.0 can handle. So maybe, but that's a $200 per month package. But
Yeah.
200,000 tokens.
Yeah, our choice was based like also on price. You know, at the end, our production run, we did it on 3.5 rather than 4 because it was good enough for the task. We would not want to spend 30 times as much, right? But the longer tokens would not be something that we would be interested in now, because we could manage to get a single metadata, like even not the largest, because there's 2 largest metadata samples that have to, you know, they're way too large for anything because they attach the OTU table to the metadata. It's terrible. But even the largest one fits. So we don't need the 200,000 tokens. Yeah.
Very briefly, so when comparing the results after the improved prompt between our human volunteer, thanks a lot again for this, and ChatGPT, like what were some obvious issues that GPT had? Like things that were easy or manageable for the human, but the model was really struggling with. Did you see any cases like that were real case?
Like the coral samples that sometimes get to water and sometimes to animal, they are, you know, like that. But I think GPT in a way makes the kind of like same mistakes like with the rhizosphere and the sediment. Those are the ones that pop up now in my mind. What would you think of? What
so
samples?
sometimes it could even be human biases, maybe, that we somehow tend to associate these samples to one particular type, like corals, or of course they're animals, or of course they're water, where the model would have maybe a slightly different view on it. Could it be?
So, something like where GPT did better than a human. I think I made something like that. But then it's, then I am assuming that my benchmark is better than yours and it's more close to GPT, which is, based on what.
That's true.
Now that you've run this and you have like these keywords annotations by GPT, like I mean, like another question is like, oh, like who would review all of like the predictions and like verify that they're right? Could you imagine like down the road using another model to like try and highlight potential discrepancies of like reviewing keywords versus raw text to figure out what are things that are most likely to be wrong or most need like human reviewer to verify? Yeah,
you could use human like curators, human reviewer to verify like a set number of sample, random. You could also ideally use a model, different models, to do it for free and to do it many times and then take the consensus. That would be ideal, right? Because I think, the consensus is, you ask the same question many times and then you take the majority. But as long as it costs money, you cannot repeat that so often, right? But humans, I don't know. It was very boring though. The task of benchmarking was like 1,000 sample. It felt, I can do it quickly, and it's like because you see how the metadata is like, right? And you have to find the keywords. Yeah.
I'm wondering, some things might be quite easy to flag it as wrong. For example, when it invents a new category and puts something in there, GPT, could you then like repass these so that you basically flag the ones that are very likely incorrect because, for example, the category doesn't exist, and would that also improve classification?
It would not learn, but you could say if it doesn't fall into these categories, you can try again. Yeah, definitely. And for the biomes, you can see there were only like out of 5 biomes that you make it pick from, strictly pick one, don't say anything else. And then sometimes it says like food. Food, but there were enough that grouped into food, so I kept them. But the ones that are really out, you can repass. I don't want to spend too much time because also it's Jamie now. But if you have questions, come later. Yeah. Do I need to do something to you just continue?